Hey guys, welcome back to Data Science with Mohammed. Uh, this should be the second video we're making in this tutorial, and this will be a very long video, maybe 1 hour long, because we are going into Python. We want to learn what Python is, how to work with Python, how to write Python code. Although we already installed Jupyter, and then we can literally work directly in Jupyter and use Python directly as we did in the last lecture. But I want you guys to understand Python outside of Jupyter. You understand me? I want you to understand Python outside of Jupyter as normal developer. So you can use Python for other things, not just data science. You can use it for web scraping, you can use it for web development, you can use it for a lot of things you can use it for. So Python is a very people use Python a lot in different department and different industry. Now, to move forward, we are going to install Visual Studio Code. So Visual Studio Code is a code editor that you can use to write to use along a lot of language, Python, Golang, JavaScript. So it is a very good tool to have on your PC as a developer. Now you can see this link on my computer, so just copy this. It will be in the description. Go to the link and then download for your OS. Maybe you are using Windows, or you are using Linux, or you are using Mac. So as a Windows user, I'll click on this and it is going to download for me. So download it. The downloaded file, you should install it. So after you install it, you should have this app on your PC. So you understand, when you download or run it, you should open it and then move to the next step. Now that you already downloaded what was it called, downloaded VS Code, now we need to install an extension. Come to this, you should see this icon here, click on it, then search for Python. You can search for it here, Python. I already installed mine, that's why you can find it there. You see, you should search for Python. This is it here. Click on it, then you should see an install button here, not uninstall. Install. You should install your own. You understand? I just updated my own, so I have to restart it. So install it, enable it, and let's move to the next. Let me uninstall so you can see the. Oh, I don't want to. Just restart it for mine. You can see, install it and enable it, and then you can move to the next step. Now that we already uninstall Python, we already installed Python, and then we can work with anything now. When you install Python, you can run Python from your terminal. So let's open terminal up in your VS Code. If it is not open already, just click on this button here and you should see terminal here. You see, terminal is the way you can talk to your computer by writing text. You understand? By writing text. So some some you know some commands in your terminal is ls. Ls means to list all files in the current directory. You can see all files will be listed. You understand? So uh, I I actually communicated with my computer by just writing text. See, if I want to create a folder on a normal day, to create a folder, you have to come to your PC, then do all these things and create. You understand me? But with command with terminal, you can use text. If I want to create a folder, I can just write make directory. You can see mkdir, make directory, and I can call it anything. Maybe let's call it test or tutorial. You can see make directory tutorial. That means create a folder named tutorial, and this will work out. You can see it worked. So as as we make directory, we created a new folder. As you can see now, when we click on, when we use ls again, tutorial is there. Let's delete that tutorial now. I don't know, I'm actually using, okay, it works. Rm for remove, underscore r mean recursive, like remove. Remove works for a file, so we use .r for a folder. You don't have to worry about all this now. I'm just letting you know there are ways we can communicate. If you click on if you write ls now, you can see there's no tutorial again. We deleted it. So we can communicate with our computer from by using text from the terminal. So now let's move forward. What do we want to write? We want to introduce ourselves to Python. So to write a Python program in the computer or on your computer, you need to write a text or a text file with the extension of .py. That is, we already installed Python by installing that extension. VS Code is going to install Python for you. Now, to .py are the files expected from your Python program. You see, if we run Python here now, it is going to run because there is a program running on our PC called Python. You can exist like this. I think that is going to exist. So you already see it. To run this Python, it expects some kind of .py file. Let me explain what I mean now. To create a file on your PC or on your PC from terminal, we created a folder using mkdir. To create a file, you can use code because we have what's it called? We have VS Code on our PC, and code just means VS Code should create a file for you. So just write code, then the name of the file you want to create. We can write code and intro.py. If I do this, a new terminal is going to open. A new file is going to open called intro.py. Just click on enter after you write this, and you can see it. There's a new file here. Click on Ctrl plus S to save this file, you see, and it will be saved on your PC. So let me open a folder here. I will open the tutorial. You can see, okay, now we have two files right now. The first file, the one we created just now, is intro.py. So let's come there. Now we want to try to explain how the software works for you guys. The first thing I want to introduce to you guys is coming first. Okay, let's not forget the goal of this video. By the end of this video, you should understand the syntax of Python, and then you should be familiar with writing Python. That's why I want it to be a very long video so you understand everything. Now we want you to understand, I'm talking about .py files and how your Python software or Python program expect .py to run. Now let's write a very simple program. You can see autocomplete is in, because we installed an extension. You can see autocomplete here. Now click on print. You see, if you want to call a function, you write the name of that function. Print is the function we want to call. Print is a function that comes with the Python software from Python developers. So then you click on this parenthesis, and it is going to, you open and close it. Because we are using VS Code, it does that automatically for us. Now you can just say, on a normal day, if you are just getting started in the computer world, the first thing you are going to print is hello world. So we tell our program to print hello world, save it. Now let's run it. We said we are going to run it from our terminal. You understand? So we have the Python program, call it Python, then the name of the file you want to run, intro.py. Let's see what happens. What happens? It prints what it follows your instruction. You tell Python, okay, when I run this file, print hello world to the terminal, and this is what happens here. You can see hello world. Let's print one more. Print. I think we printed this the last time. We save it, then just run it again. Python. You can see, welcome to data analysis with Muhammad. So if you want to run Python, you install the Python program or the software on your computer by installing the extension I showed you. Then you create .py file that you want to run, and then boom, you can just run it. Hello world, welcome to data analysis with Muhammad, and it works just fine. Oh, now moving forward, we should talk about types in Python. So you can see I created a file called code. I said code types.py. You can see here. So I will save the file now. You can see it in my saved file. Now let's talk about it. We have types in programming language. You understand? Oh, you see the way I created this file, it is overriding the standard library module. So let's just rename this file to something else, so it will not override. There's types in the Python program already. You may not understand what that means, but let's rewrite this. I can just call it custom c types. Now we said, let's talk about types. We have int, we have float, we have string, we have bool. Now what does those guys mean, and why does it matter in programming? you know computer understand only numbers. The only thing computer understand is 0 and 1. Not just numbers, 0 and 1. Your computer understands 0 and 1. So it is the developer responsibility to take everything you want to talk about, a lot of files, a lot of names, a lot of numbers, and tell the computer how to represent it in zeros and ones. So it is the developer responsibility to do that. Everything your computer understands is just 0 and 1. So that's why we have types in computer, in programming language. When you want to use numbers, that, like you said, integers and numbers in Python, numbers without decimal place. Like you see now, when we said age equals to 25, you understand? Age equals to 25. 25 is an integer, 40 is an integer, 50 is an integer, minus 10 is an integer, minus 25 is an integer. So numbers without decimal place are called integers. They are the integers in programming language. Understand? Now, if you need decimal places in programming, you use float. We call it float. That is to say, floating points. You see now, this 5.9 is a float, 5.10 is a float, 5.1000. Anything with point at the end with a decimal place is called a float in programming. You understand? This is an integer and this is a float. So that's it. We know what an integer is, we know what a float is, right? Okay. Now, the third one, we said we need strings. What is a string in programming? A string is like a letter or words. Ali, Muhammad, not numbers but words. Anything in words. So to represent string in programming, use this. Just write this, and you have a string in programming. You can use this one, the single one, or you use the double quotes. Sorry, quotes. To represent strings in programming, you need quotes. You can use the double or the single quotes, but use the double most times. So you can just call this Muhammad. That's a string. And we have another type called the boolean. The boolean, it is a true state a two-state words or condition, sorry, we have the true or the false boolean. You can see true or false. That's it. The boolean is, when you are trying to know situations, did this thing happen or not? Is this thing correct or not? So you use a boolean to get the state uh of of that situation, if it is true or false. So anything true or false is called a boolean. Now let's you can see here, to know the type of any variable you create. I will explain what a variable means in a bit. So to understand or to know what the type of a variable is in programming, in Python there is a function that comes with the package that is called, understand, it is called type. Is going to tell you the type of that variable. Now with this function we write, we already tell you or told you what print is in programming. It is to print something out to your terminal, and then we are saying, okay, print the type of age, and then the type of name, and the type of height, and the type of student. You see, if you want to print a lot of things in one line, you can just use the comma. Or if you can also try, you can also print it one by one like this. You understand? So let's just print it all one line. So let's run this. Run it as we did the other time. Just say Python. Then the file that we want to run now, we call it ctypes.py. Then it's going to run it. As you can see, the first one said class, type of int, class, type of string, class, type of float, and then class, type of bool. Understand? So that's what it is. Yeah, so that those are types in programming. So if you are writing a program now, you are writing anything, maybe a script or a program, and what you need in your programming, maybe you need the age of your user. So the first thing that comes to your mind is you need to represent that in an integer. So you need to represent it with an int. So if you want to save the value of a division value, of you are writing a calculator, for example, and you want to save the value of a division program or a division result, the best way to save it is using a float. So because you can sometimes you can divide by, you know that by numbers that's going to give you a float. So you should save it in a float instead of integer. If you save it in an integer, it is going to round up, but if you save it in float, it's going to, just push out the result in float. Now if you want to save a value of a letter or words, then you need a string can write a very long word. Not just, you can use it for sentence, you can use it for a complete paragraph. Yeah. So when we can try to print that name on its own, not the type of the name. Now see, printing, we are already writing programs already, so it is not a big deal. You can see, my name is Muhammad. You can see it is printing out. You can use it for a complete paragraph and all. Yeah, that's it. So we are done with types. And then it says here why dynamic typing matters in data science. Okay, we are not done here. There are different type of programming when it comes to typing. When it comes to typing, Python is a dynamic typing, and there are other programming languages that are static. What does that mean? So you see, we said age is 25 here. Now let's come back here and reassign and say age equals to 25. You can see what is the difference between the way we save the age or the way we store age here and the way we store age here. The first age is stored as an integer. We said 25, just the number. And the second age is stored as a string because we save the word in English language, that is 25, not just 25. So when we run this should work fine. But if you notice the first time, let me clear this. The first time we printed, let's comment this out so you understand what I'm trying to say. Let's run it first. You see the type of age here, when we say print type of age, that's it here. It is the first one here. It says it is an integer, right? Now let's uncomment this, then run it again. It said our age is a string now. Why? So in programming, the last declaration or the last assignment in programming, you see this equals to sign is called assignment sign in programming. You're saying my variable age should be assigned this value that follows. So we are assigning something to age. At the first time we assigned an integer, and then the last line here we assign string. So in programming, the last assignment is what is going to be output as the output to your end user or to the terminal. So the last thing we assigned here is a string. That's why when we print the type of age here, we are getting a string. So the reason we said Python is a dynamic programming is that you can assign any type to any variable. But in other programming language like Golang, when you assign an integer the first time, anything you are assigning here will not be the same thing as 25, but must be uh, an int. That's what we call static typing. So this type of programming language, you cannot assign one type as you can't even assign a float to an integer variable. So anything you are assigning must be the same as the first, the same type as the first assignment. So, but in Python, you can do anything you like. At the first time, we assigned an int. If you want, you can assign a float here, and then it is going to work. You can see it will tell you it is a float now. No, I haven't saved this. Ctrl plus S to save. It is going, you see here, it is going to tell you it is a float. Yeah. So you can assign and reassign. Even if you want to assign a boolean, just write true, save it, and it's going to tell you it is a bool now. So you can assign and reassign. Now, the last point in this section is that why does dynamic typing, why does it matter in data science? When you have a lot of data, you can be given a lot of data. Different type of gathering of data is outside in the world. People can gather data in integer. Maybe they want to save the age in 25, 24. They can also decide to save that same age in plain English language and just write 20 TWNTY. You understand? So that's why this is going to be, it matters in data science. You don't have to worry about changing data type. And then a lot of packages like pandas and the packages we are going to be using, they use this dynamic typing to take care of a lot of things under the hood. So it actually matters in data science. So thank you, and let's move forward. Now, since you understand types and all already, so let's look into strings and numbers. Let's just look into each forward. What can you do with strings and what can you do with numbers in Python? So if you see this data, you know this is a string already, right? And if you see this, you know it is a string already. So what can you do with it? We said first data and second science. We have a data and we have a science in different variables. And our aim is to print this out in full as data science. Let's comment everything else out. Understand? We want to print all this out as, understand, data science. What do we do? How can we do it? You can use the plus sign. You can achieve this in different ways. By using a plus sign on a string in Python, you are just telling Python to combine the two variables together, data plus science. So let's print this out. If you run Python SNN, now this just means strings and numbers. You can see, okay, I said there is an error. This is not saved yet. can see data science and data is fun. How do we achieve this? By using the plus sign, we said data science. This is a space. If you remove this and just say data plus second, first plus second, there won't be any space. So that's why you can see here, that's why we have that space in between and it's saying data science. That makes sense to you. And we want to say data is fun. You can decide to just use data directly and just print it directly. Say this way, print data is fun. You can do this, it will work. But we already have data somewhere at the top. We already declared it before. So how can we use it without saying data explicitly again? So just save this and let's explain what is here. You say this F sign here just means format. You're formatting it. You can do this in two ways. We said F. Yeah, leave it. Just leave it like this. If you want to use it another day, you have a variable you already declared before and you want to use it in your string, you can use the F, that is the format function. This is it, print, or anything you want to do. You can say, let's do this. We said end, okay, final word. That is the end of the word we want. We will declare the variable and we want to assign it to what we get here. Use the F to do a formatting and then use this double quotes. And the next thing you do is write everything you want here. We want our variable, this first variable, we want it here, right? Just use this sign and then put the first inside and everything is going to work fine. You see, we already declared the final. Instead of printing it here, we can copy this, bring it here, then just print the final word. So that's how everything works in the programming world. Run it again and you can see we have data is fun. You see, just play around with things and you will get the end product that you want. Now let's work with numbers. We have string. We know what we can do with string. We can join two strings together. We can, you understand, we can join two strings together. We can format strings and then we can save it in a word and print it out. There will be assignments on everything we are talking here, so just pay attention please. Now what can we do with numbers? We can do all arithmetic functions that we have in mathematics with number in programming language especially, and also in Python. So we have multiplication, we have addition, we have division, and you can name it power. Now to do multiplication, all you have to do is print 3 plus 10. That's addition. That's an addition. If we run this, we're going to get what? 10 plus 3, 13. So let's do the subtraction. No, sorry. Let's do A plus B. So A plus B is going to give us 13. Now A minus B minus 3, it is going to give us 7. Can you see the output here? And then A times B is going to give us 30. As you can see, A to the power of B, that is 10 to the power of 3, 1000. As you can see, you can also do, can see B to the power of A to the power of 10. You can see that's it. So that's how it works. You can think of it. Division, A divided by B, and it's going to give you your answer 3.33335, and it's going to give you a float. If you remember, I said if you are doing division, it is better to just save it as a float. Yeah, and then we have type casting. And then in Python, see this last line here, we want to output our age. We said age, okay, age is not defined. No, When you have not declared a variable and you are trying to use it, you are going to get this error. Let's just say age equals to 15 and that error is going to go away. You can see that's how to declare variables. Now we said we want to print out age, our age here. Let's run this. Age equals to 15. You are trying to see this, but let's do this. Is this going to work? Let's see. As a type error, we can only concatenate string, not int. When we are trying to join two together here, we are using plus. We said we can use plus to join two strings together, but we want to output age is 15 like this. How can we do it? That is, we are going to change this our age into string. Do you understand? We are going to change this variable. We declared it as an int, but we are going to change it to a string. So there's we call it type casting. You change from one type to another type without redeclaring. Though if you want to redeclare, this is what you do. Age equals to 15, as you can see here. And if you run this, it is going to work. But we don't want to be writing everything. You don't know what your user is going to input or something like that. So you can just do age equals to the string version this, and it is going to work. Python age equals to 15. So that's it. When the aim of this tutorial is to teach you how to do things yourself and how to get things done. This is type and this is typecasting. Watching videos, following through, you should follow through, and then you should run all these things you are watching, because there will be an assignment to make you, if you understand everything you are going through. This is a 1 hour video. We expect you to watch it throughout this week till next week, or even if you can do it just today and tomorrow, you should be done if you can. But if you are not understanding, take your time. In every section, just watch it maybe 1 minute. Watch a section, try to practice it before moving to the next section. Thank you. Now, since we talked about uh, types in Python or in programming language, because the types that we talk about here, you will find it in many and others programming language. Now, I call this section explicit types. In programming, they are more like implicit and explicit type. The implicit are the main types, the lowest types that you can find in programming. Those are ints, uh, string, float, as we said already. Then this one that I called explicit, that the type of list, list, for this one. Two, we have dictionary or mapping or map. We can call it map or dictionary. Third one, list, dictionary, set. In Python, we also have tuple. I don't know how it is called. These types of type, they are like explicit. They are from the implicit. They are more like a way to use those int, string and all more better. As a list, let's talk about list now. For number one, list, the collection of objects, is a collection of objects in any programming language. Do you understand? The collection of objects or variables. We can call it that way. Let's create our first list. We want to call it. Um, let's do this. Say house one goes to else. Let's say we are saving the location of houses in different states in Nigeria. We are developing an app for relocation or address mapping. So we are saving the location of houses that we want to work with in our program, right? We say house one is Lagos, house two is in Ibadan. House 3 is in Kwara State. No, now we want to save like 100 houses. We want to store like 100 houses. Maybe each user are going to, you know, input the houses they lived in the program. By writing house one, house two, house three, house four, we are going to write house 100, and everything you are using here is using spaces. They are using space. So creating a list will not really save space, but yeah, they are using spaces, and it is tedious for you as a developer to write. Now let's do this. Let's say houses. We are going to save all our houses here. We just say equals to a list. This thing that you see here, this is how we create a list in Python, by using this bracket. Do you understand? Now we said our houses will be stored as a list, and we said a list is a collection of objects. Our objects here are strings. We just want to save a lot of strings inside this list. So this is all you do. Just bring all these houses that you are saving there and put it here. Lagos, Ibadan, Kwara. This way we save all our houses without having to write it one by one. If you want to save 100 houses now, all you have to do is just keep going here. You don't have to declare new houses again. Now, you know, this, okay, we should not go to dictionary yet. Let's talk about how we can work with a list, the operation that you can do in list. Now, we said this is all our list. We can print it out here. Print houses. You see, to run it, just run. As you can see, if you want to run it, we do Python, then the name of our app, and the name of our script that we want to run, of the file that we want to run. If you want to create a complete folder, there's a different way. You just run python main.py, but we are running the file that we want to run directly here. As you can see, it prints all the houses out: Lagos, Ibadan, Kwara. Now, a new user is in our application now, and they want to add someone living in, oh, what another state can we think of? Lagos, Ibadan, Kwara. Wow, I don't know state though. Okay, Jigawa. Okay, let's say someone is living in Jigawa. Now they want to add it. Instead, we already created it. Our application is here. This is running already. We don't want to input it here directly again. This is all you can do. We want to add new house. That is, we want to append house at the end of these houses. This is what you do. You houses dot append. So append is a method on all lists in Python. So these are methods in Python. We can call this append. The list that you created here, then dot append. That is the function that we want to call. We want to append a state. We call it Jigawa. You can see. Let's see what this is going to do. Let's reprint house here. Our program is going to run from up to bottom, right? Let's save this and run it again. It's going to print two things out. Let's see how it works. You can see here, the first one that we printed, there's Lagos, Ibadan, Kwara. And here we said this house they should append another state called Jigawa. And at the end, we print it out. And you can see here, there's a Jigawa here. So this is our list at the end of the day. So this is what our list look like. So what does this mean? After you create your list in Python, you can add to it, you can remove from it. So let's do this. So we have a remove function, houses dot remove. To call a method or a function, you use this. So what are you going to remove? Okay, let's run this first, then print it again. See, there is an error because I think there is a remove index. Come in. That is definitely not correct by 120. So it's not okay. You can see here there are errors here, attribute error. So when you are running programs, you are going to meet a lot of errors. So when you see errors, don't be scared. It is normal in programming. You see errors and you solve it. So you that is called debugging. When you see errors and try to remove your error and write a correct code. No, let's talk about remove. Remove is used to remove one uh, of these values or objects in this list. So we have Lagos here. Maybe one of our customer, one of our user is leaving our app and they live in Lagos. So we want to remove that location out of it. So we just call houses.remove. You see, when we print this, there will be no remove, there will be no Lagos. You can see here Lagos, Ibadan, Kwara. This is when we first created it. Lagos, Ibadan, Kwara, we print it. Now we add Jigawa here, we print it again. You can see Lagos, Ibadan, Kwara, Jigawa. We remove Lagos here, you can see Ibadan, Kwara, Jigawa. There is no Lagos. So these are ways to remove things, and then after removing it, there will be three more. There will be three left in our list. So and then there is this. There's another function. The index. When you want to change something in an index in your list or your tuple. I think it is also in tuple and then in set. So this is what you do. Let's talk about indexing in list first. Indexing. When you want to index, what do we mean by index? Index. You can see, okay, let's find the length of our houses. Okay, let's comment out this. Let's leave it. Houses dot len. I think there's a function called len. Print this out. If you want to see something in your terminal, you call the print function, right? So let's see what is printed. So there is no len function. So you call it this way. Len is not a method, it is a function directly. So this is how you call it. You can see, you see errors, you sort it yourself, and then this will work. See now, this print out three. At the end of this place, let's see what is here. One, two, three. So this is what we are finding, how many houses are remaining. So if you want to find how many objects are in your list, so you can find it this way by using this len function. Len and the list, your list here. So you can find it that way. So if you create a list called buses, if you create a list called mornings, if you create a list called laptops, you can just put it inside there and it is going to tell you the length of that list. So the length of this our house is three. So we have three houses. In Python, when you want to index, what do we call index? Index is the number, mean the position your object is in your list. So they ask you what, when we are talking here, we said house one, house two, house three. Now you are writing your program and you want to get the first house in this program, the first house in the program left in our list. So let's do this. We want to print the first house left in our list. This is what we're going to do. What is the name of our list? We say houses. Then you use this bracket like this. Now, as a normal mathematics or normal counter, you start from 1. You said we want the first house. So in your head, the first is 1. If you input 1 here, let's run it. See, can you notice the last? This we are using this list here, Ibadan, Kwara, Jigawa. So notice though, let's run this again. Okay, we have not. We should print this house. We should print it so we can see it in our terminal. Print. Okay, I made a mistake. Print house 1. What you can see here, Ibadan, Kwara, Jigawa. But we said we want the first house, but Kwara was printed. That is this second one. So the thing is, in programming, most programming language, index they start from 1, from 0, sorry. indexes start from zero. So if you have three objects, your indexes are 0, 1, 2. If you have 4, 0, 1, 2, 3. If you have 5, 0, 1, 2, 3, 4, 5. So let me write this note so you can see it. In programming, indexes start from zero. So you should note this down. As I'm making these lectures, make sure to have a note. I have to tell you guys that have a note, note this down. In programming, index starts from zero. So since we want the first house, our first house is Ibadan, right? So we want Ibadan to print out here. Let's see if it is going to print Ibadan. And here you can see Ibadan was printed out. So that's list. That's list for you. You know, there are more things you can do with list, but as we go forward, we'll talk about it. So now let's go to dictionary or mapping. So in programming, mapping is also like a collection of objects. It's a collection of objects, but the difference between mapping and list is that in list your index are automatically given to you, and you have to just list all your uh objects. But in mapping is a key to value kind of storage. It is a storage like list that it is a collection of objects like a storage, but mapping, it is a key to value storage. It is just the key to value version of list. So now let's do it. We said now in our houses now, we don't want it to just be house, all those things. We want to save the house by their name. Now let's say house one. We want to say house one is in Lagos. As you can see, the thing is going. No, for you to create a mapping, I'm sorry, do you notice this? They call it curly braces, sorry. To create a list, we use a bracket. To create a map, we are going to use a braces. So that's the difference. Now let's put this here. We said house one is in Lagos. House two is in Ibadan. That's it. This house one, everything here, everything here is called a key. Then the value that follows, you write the key. Let me just make a comment on how to write a dictionary. First, you give the name of your dictionary. You call it dict name. Then you said equals to, equals to is the assign. Then this is the sign of a dictionary. Then here write your key, you write a column, follow by the value. So if you want to add more, you just use comma, then add the next one, comma, add the next one. So that's how you create a dictionary. So plus one is a is a key, and then Lagos is the what? Is the value. House two is another key, Ibadan is the value. So that's how you create a dictionary. If you want, you can just we want to create a list equivalent of a dictionary. You can see here that you see in our list we said house zero. If we are using 0, 1, 2, 3 as the indexes. So you can just use the index as the key here. I want you to notice something. First time we are using a string as our key. If you remember, a string is a word. The second time here, what we are doing here is using a number or an integer as our key. So you can do either of the two. Yeah, and we call this Quara. Then the third one, we call it Jigawa. So you can use a string as your key, or you use a word or a string or a number or integer. So you can do that. You can even use you can do a lot of things, but this is an introduction video, so we don't want to get deep. You can make objects your key. You can make object your your value if I am correct. But we are learning together. If it is not correct in the future, we are going to know. So yeah, this is houses. So depending on what you need in your programming, you can just do this. Let's print all this out. Print houses. But wait, we can just comment on the one we are doing before. All these codes are going to be available for you. If you are following this, I will upload it to GitHub and then you can download it. So if you are following, you know what to do and you know where to start from. So yeah, that's gonna be it. All you have to do is just comment it out when you are working with it. Now, you see, now let's print houses. When we comment, you see, everything I'm doing since morning by adding an hash at the start, I'm commenting it out. So when you comment things out of your program, your Python is not going to treat it as a program, they treat it as a comment. They will not run it. So that's why at the end of the day, it is going to start running from this place because we have commented out everything. Now let's run this. So we print houses. You can see 0 Lagos, 1 Ibadan, 2 Kwara, 3 Jigawa. Now to access your value in in your map, in a map, what you do is like the way we did in you know a list. You are going to access it with an index or your key. Sorry, you are going to access it with the key. Let's say we want to access Lagos. You access Lagos with the key that you define here, that's 0. You want to access Ibadan, you access it with the key here. If you notice, when you are creating a map, you cannot use a key two times. You can only use a key one time. That is, a key is always going to map a to one value. You don't have one keys that map to different value. So you can't have your key two times. So you only have key one times. If you do this, you can see what. Let's see what happens. The key should only map once. Maybe because Python. You can see, yeah, because Python is what? Python is kind of dynamic. The end, we said one is Ibadan here, one is learning here. So it is regarding this one. It is just like you are assigning something. But in other programming language like Golang that are very strict, they will not allow this. You cannot reassign here. But even though you are still reassigning, your key is still mapping to just one value. It is overriding this one. So when we remove this back, it is going to map back to Ibadan. So yeah, when you print it, you are going to see Ibadan here. So let's say we want to print Jigawa out. You just do this, and you are going to see Jigawa. Let me show something else. Let's say house one. You can see if you use one here now, it is going to bring an error because one is not a key. What is it going to say? Sorry, zero. I mean zero, not one. Zero. Zero is not a key, so it is going to give you an error. Key error. There is no key named zero. So when we change it to house one, it's going to work and it's going to give you your Legos back. You see? So that's how things work. Yeah. Now let's go to a what? Tuple. So when you want to create a tuple in or a tuple, I don't know. When you want to create it in Python, you just say T equals to, you see, 5 1 or something like that. This thing is mostly useful for maybe you are declaring a dimension or you are declaring a point. In mathematics, if you are declaring a point on a graph, you need the x-axis and the y-axis. So instead, this is the most suitable type to use. They call it a tuple. Yeah. So you can print it out. Print t. This should be fast. You can see index. You can use index for t2. You can see 5. You understand, right? Because I've already explained it in list. So this is the tuple here. 5 1 5. If you want it to be 3, You can see, and then to the second one will be 5. So we have a set. In mathematics, there is something called set. A set is also a collection of what? I think a set is a collection of distinct objects. In sets, so one of the difference between set and these two is that in in a tuple, you can have more than the same value. This is a 5 here and this is a 5 here. But in set, you can only have one value at a time. So that's the difference. So there is a set in Python. So when you want to have distinct objects, let's say you want to have objects that can only appear once in your collection. So if in mathematics we call it a set, you cannot have one twice, you cannot have two twice, you cannot have three twice. So let's say you cannot use list. So you want to make it compulsory. Although you can use list to represent a set, but you have to make some programming decision that make sure your user is not adding two same variable at the same time. You understand? So now to create a set in Python, we can just say s equals to set. You can see here set. Let's say one. I'm coming. You can see this set function can help you turn. Hmm, let's create a list. You see, we are working this together. Let's create a list. S equals to, you see something 5 5 5 4 3 2 7 8. Let's just use different number. So you want and then you want the unique values of this list. Let's say you want the unique. We have a lot of five. We have five, a lot of five, maybe six twice. But you want the five just once. You want the unique, like you said here, build an unordered collection of unique elements. The unique element of the list here. So you can use a set. A set is going to get all the unique elements here. Let's run this. You can see here 0, 2, 3, 100, 5, 6, 40, 426. You can see no variable is happening twice here. Everything is what? Just one. This is our list. We turn it to a set here and we get unique variables. So I was saying this was just a way to create a set from an already defined list. Let's say you want to create your set directly from the beginning. You are going to use this curly basis. But you remember here, you are not going to include a key. For map or for dictionary, you need a key, but for set, you don't need a key. Let's say 5, 6, 7, 8. This is going to work because all these things that you can see 8, 5, 6, 7. Now let's input 8 again. Let's see what happens. You can see even if you put 10 8, it is going to output just one 8. That's what's going to happen here. You have a lot of it, and at the end if you print it, all you're going to have is just one 8. You can see that's what set is for. It is going to just take the unique elements of all these things that you listed. Now you can create a set by just doing this also set. You see, set s dot, I think, is it add. You can add one. You can s dot add two. You can add two. Now, if you print, we just create, you should get a set of one and two. You can see one, two. If you try to add one again, at the end, you are still going to get one and two. Yeah, you can update, you want to change. Let's see how this update works. Just leave it. You can. You don't want to get too deep. Yeah. So that's it. Now let's talk about something very quickly here. There's something called uh, mutability in programming language. Mutability is the idea of changing something after it is being created. So if they say something is mutable, that is, we can change it after we create it. If it is not mutable, we cannot change it after being created. A list, okay, list mutable objects. List is mutable. List, dictionary, dictionary is mutable. Is a set. A set is mutable because you can add to it. You can do s dot add. So, but one thing that is not mutable is a tuple. You cannot change a tuple after it is being created. So let's try it out. You already see list. Okay. Let's say I just want to show you if something is mutable or not. If you can change it, it is mutable. If you cannot change it, it is not mutable. Just listed all this out of my head. These are things we just learned now. So let's check if we can mute uh if we can change a list. So L equals to 1, 2. You see, this is the state of our list here. Print L. Let's save it. Let's run it. This is what you see now. But let's clear this. See 1, 2, 3. This is the state of our list right now. But let's say L dot add. No, no, dot append, sorry. We are not redeclaring L. This is the same L here, but we are appending another object to it. And we say 4. When we say print L, what happens? If this is not mutable, it is going to tell you an error here, but it works. The state of L here is 1, 2, 3. The state of L here is 1, 2, 3, 4. So it is mutable. We can change it. So yeah, you can just say, even you can say here L, sorry, you can say let's change the first object or the first element in our L. We say L first. Our first L equals to 5. We don't want it to be 1 again. And if we run it, what's going to happen? You can see 1, 2, 3, 5 to 3. It is changing. So we can change list. Let's check a dictionary. D equals to, so 0 equals to, the first object here is 5. The second object is 2. The third object is 7. So let's print it. This is our first state of the dictionary. Now we said the fourth value is 100. Let's see what's going to happen. Print, oh sorry, this should be equals to not. Print what? Print D again. You see, when we declare it, you can see here the first one that we declare here, 0 is 5, first object is 5, second object is 2, third object is 7. We now tell the dictionary we created it here, we did not add the fourth object. We now say we want to add the fourth object here, and the dictionary accepted it and it is added. So when we can add, we can remove, we can delete, then it is mutable. You can see here it is mutable. We prove that. Now let's see for set. Okay, as we said, a set, we say S equals to, you can see 1, So okay, that's a set. S dot remove one. We can remove the one, and when we print it here, print s. Since there is a function like remove, that is, we can modify it, then it is mutable. It is mutable. Let's run it. You can see here 1, 2, 3, and when we print the same s here, it say 2, 3. So, and then we can also add. Yeah. So we said a tuple or a tuple is not mutable, right? Now let's create one. We said t equals to 1. This is how we create a tuple. Let's say 505. We now said t 0 is what? Let's print it. We can index, that is, we can access it, right? Let's print the first one. You see, it print 500. But let's try to change this 500 to 100. T0 equals to 100. What's going to happen? It tells you what? You see, object does not support item assignment. You cannot update this. You cannot update it. If you want to change it, you have to change it in the declaration. You have to change it in the assignment. You cannot reassign. If you cannot reassign, if you cannot change, that is, it is not mutable. In other programming language, some object may be mutable, that is not mutable here, and some, but in Python, this is how it is. Now, let's move forward. Okay, guys, let's talk about conditions. Conditions and loop. First, we are going to talk about conditions. One of the things that make programming language very powerful are conditions and loop. You know, if we can just do something once in programming, if you use your Python script and all you can do is once, and it is only one way every time, it is less power for your program. But with conditions and loop, your program can have thousands of ways. It can be dimensional. It doesn't have to be static. You don't have to just use one thing at a time. You can define a lot of conditions, and you can define a lot of repetitions, repeating in your program. Now let's talk about conditions. Condition is a situation where you want your program to decide something based on a condition or based on a fact. Now, let's say my program, if my user is older than 20 years old, we count them as adults. But if they are younger than 20 years old, we record them as what? As not adults or a young person. So how are you going to do this? You know, if all you can do is just write a straightforward thing in programming language, you can't get this done. Now let me show you how this is done. We said age. Let's declare an age. We said our age is 25 25 years old. But this program that we are writing, we want to know if someone is greater than 25, if someone is greater than 20, they are adults. If they are less than 20, they are not adults. So how are we going to do it? You can do this. uh, you have to use an if. You have to use an if statement. What is it called? If statement. If statement. You can't just print age or something. You have to use an if statement, then decide based on that. So in programming, something called conditions. In almost every programming language, you have the if else, and then the else statement. So let's do this. Then if age is greater than or equals to, see, we can just say if it is greater than 25, print adult. Do you understand this coding here? If you bring your print here, if you do this and bring your print here, this is not going to work. You can see expected indented block. Python is an indent language. You have to indent. In some programming language, you have to use different way. Okay, in Golang now, to declare a function, this is what you're going to declare an if statement. After you did it, you do if something, then you are going to use this and then write all your code here. But in Python, you don't do that. You said you declare the if statement, you put this colon, and then everything you want under the if to execute under the if is going to come here. If you want something to execute under this if, you have to indent. On your programming on your PC, if you want to indent, you press the tab button. If you want to indent, yeah, you can see now everything that goes under here is going to run under this if statement. So if we want to print r dot directly in our program, if we do this, let's comment this out, delete it entirely. Let's see. If you run this Python, you can print. You see, it is going to print r dot here. You can see. Let me just do this so you can see it well. I don't know if you're seeing it. So this will make sense so you can see it well. So this is what we want to print here. So you can see it very well. You can see an r dot was printed. So we print r dot, but we don't just want to print r dot. We want to determine if you are going to print r dot or not based on this age. Now let's copy everything we have here. We can copy everything we have here and put it in our. We said if age is greater than 25, you can see now print. See, this is not an index. We need to put everything under the if statement. So it will run with the if, not directly from our main or from our file. Now, if we do this, you see, anything is not printed. I run this again, we did not print anything. Because of what? Our age is not greater than 25. You can see here, our age is not greater than 25. This is what else you can do. You cannot say else. Let's say this user is not greater than the user is younger than 25 years of age. What should we do? We should print young, not an adult, or not adult. Now let's run it. You see what is printed? Not adult. We said if it is what else, print this. If this is correct, print this. If this else, that is if this is not correct, print this. But we don't want to print not adult for a 25 years old. So there are two things to do. So if our user is equals to 25 years of age, now between all this you can add another statement called leaf. It is called an else if. Else if. That is, if this one is not correct, fall back to this. You can have a lot of else if you have a lot of conditions. If this is not correct, come back to this. If this is also not correct, you can have another leaf again. You can also have another a leaf. You can have a lot of else if. And if all those conditions are not correct, they are going to fall back to the else. So now let's have an else leaf. To use an elif, you need have an elif, you need a condition here. An else doesn't need any condition, but an elif, just like if, you need a condition. We said if age equals to 25. So if age is 25, you see, if age is greater than 25, then an adult. If it is equals to 25, they are also an adult. The only time they are not an adult is when it is less than 25. If you don't want to use an else, you can just change it to a leaf age is less than 25. But that's just repetitive. You are just repeating things because at the end of the day, your programming language already understand it. So you can just leave it as else. You can see this is going to work. And we are going to get before we get not adult, but since we add an equals to here, we should get an adult because 25 years old is an adult. Doing this equals to is also, you are just repeating things. You can remove this, and in your condition you can say if it's greater than or equals to. In this if, you are doing two conditions together. You are using two conditions together. This means greater than or equals to, greater than or equals to. And if we run this again, we are going to get adult. So that's what conditions are. In programming language, or and in Python, I mean in Python, if you want to use conditions, you have your if. If you have more than one conditions, use your elif. If you have a lot of conditions, just keep using elif. Condition here, then this, you can see your condition here, condition here. Now let's say then you can have a fallback function called the else. That is, if all these things are run and none of it is correct, just run this. Just run this last one. And those are conditions in programming language. The next thing we are going to talk about is loops. They call it loops. Loops.py. Let's look at loops.py. What is loops, or what are loops used for? In programming language, when you want to do something more than two times, more than one time, sorry. Let's do this. We want to print Muhammad. Let's say we want to print Idris 10 times. You can achieve this by just doing this. Copy this thing 10 times. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, let's run this. You see this. That is, it works. But in programming language, you should not repeat yourself. That's one thing about programming. You should not repeat yourself. If you use something once, you should be able to use it numerous times in programming language without repeating. We are repeating the same things 10 times, and all we have to do is just write this one time. So that's where loops comes in function in programming language. So how can we do this? We have, I think, three types of loop in Python. In other languages like Golang, we have just one loop. But in Python, we have three types of loop. We have the for loop, we have the while loop, and we have the do while loop. Now let's use the for. I don't think it has been a while I use a for programming for. Okay. Now let's use for to achieve what we want. We will use all these function, all these type of loops to have achieve the same thing. So let's use the for first. We said we want to loop 10 times. 10 times. See, okay, let's explain this. We said, so to use the for loop in programming or in Python, you need the for in range. We said for I in range. The last thing here should be an iterable object. You can use a list. List is iterable. You can create a list here and said, no, let's use the nums of loop. We want how many loop here? calm down. Norms of loop. How many loops do we want? We said we want 10. So calm down and see what I'm going to do. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In programming, we always start our index in 0, right? So when you're trying to loop, also try and start from 0. Most times everyone start from 0. You start from 1, it is but make it a practice to always start from 0. So you see norms of loop. Now let's say for I in this, we created our list ourselves. Range is a function from Python that they created, but we want to do everything ourselves, even though you don't have to do it yourself, but to understand where we are going. So we created these norms of loop 0, 1 to 9. If you count this, it is 10 numbers. There are 10 numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let's run this and see what is going on. You see, we said for I in norms of loop. So this is for going to take this object one by one. The first time that it runs, I sorry, let's clear this. Let's run it again. You can see the first time this is running, it takes, you see, we print Idris, then the I. We said for I in this. It is a simple English for I in this. The first time it is going to run, I will be equals to 0. The second time it is going to run, I will be 1. The third time, I will be 2. The fourth time, I is 3. As you can see, that's how it is going to 9. It is 0. We achieve the same thing. See, if we want to achieve this, what we achieved the last time, we can just remove the I, and you can see Idris was printed 10 times. If you don't need the I, you can just do that. Idris was printed 10 times, and that's how you can achieve it. So now we don't want to create norms of loop ourselves. We don't want to do that. So what are we going to do? We can use a range. When you say range, range is a function from Python that range from, you know 0 to the number you declare. You can see this is where you want it to stop. You want it to stop at 10. It is not going to include 10. This range is going to stop at 10. Let's run it again and the same thing will be achieved. So you can put I now and just do I. You can see it is not going to include 10 and it will stop at 9. The same thing we achieved with creating our own. You can see that's what range does. If you create, let's do this, ls equals to range 10, print ls. Let's see what happens. You can see it is the same thing as what we did the last time. So if you don't understand something, you can see now, okay, range 0 to 10. I'm coming. You can see 0, 1, 2, 3. The same thing as what we did the last time. We are just turning this range into 10. You can delete it and you understand what I mean. Ready? Clear it, run it, and you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's how it is. So if I give you an assignment and I want you to print 1, 0 to 1000, and all you have to do is just turn this to 1000. Your computer is very fast. It is going to run it. See, 0 to 1000 is stop at 9999. That's it. That's how powerful computer can be. You can see from 0 to 1000. Now, okay. See, it is starting from 0. Let's say you want to start from 1. Maybe you need a reason to start from 1 and not 0. Just put 1 here. And you can see if you do not put anything, it is going to start from 0 by default. If you put 1, let's do to 10 so you can see it. If you put 1, it is going to start from 1. As you can see, 1, 2, 3, 4, 5. But if you want it to stop by 10, it is going to still to stop by 10. So if you want to include 10, you need to stop at 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So and that's how you work with range. So to use the for function, I mean the for loop, we call it a for loop, a for loop. So this is how you are going to do it. Maybe you want to start from 10 to 100. 10 to 100, just put it 10 to 101 because you want to stop at 100. But 10 to 99, you are going to do 100. So yeah, that's how you do it. Now let's print Idris 10 times with while. You want to print Idris 10 times with while. Let's put this back to what we did. Now, you want to print in this 10 times too. Said why, see, this is how we do this. We said I equals to 0. We want to start at 0. Now said while I is less than what? 10. Print, print Idris. Idris. You see, if we run this, it's going to work. But our our computer is going to work for life by doing this nonsense. Let's do it. You have to try things out in your computer, even if it's going to crash your computer. Now run it. You see, Idris kept running, but we want it to stop at 10. You see, I press Ctrl plus C to interrupt. So when you run that, it is going to interrupt and stop it. So what can we do for it to stop at 10? Do you know the reason why this is running for life? This is what happens when your computer runs to here. It comes here. It says while I is less than 10. Okay, print this. Run this. Come back here and see I equals to xi in your computer memory and see I is still 0. Checks the condition here. The condition I is still less than 10. I is still 0. Print here. I is still 0. Print it. Because I will keep being 0 for life. So how do we update I to increase every time this is run and stop? So this is going to stop when I is equals to 10. We said while I is less than 10, this should run. So whenever I equals to 10, this is going to stop. So all you have to do is just plus I equals to 1. That is it. You are going to do so. We have not done any mathematical operation since. So our mathematical operation is working here. Let me explain something here. We say I equals to I plus 1. That's what we are going to do. That is the last I here, then we plus 1. So when it run the first time, it is 0 and it comes here. I will be equals to 1. It will go back. It will run again. I will be equals to 2. For you to understand what I'm saying, you can just print. Oh, okay. Print I alongside Idris. So let's run it and explain. So let's clear this. Okay, now run. You see, I the first time we declare I equals to 0, we print it here with I will be equals to 0. We said if you take this 0 here plus 1 and run it again, when the next time it is running, it said Idris, then I will be equals to 1 because it is already plus with 1 already. So the third time it runs, I will be equals to 2, then it will be plus with 1, it will be equals to 3 here, plus with 1, the next one before, plus with 1, the next one will be 5. So when it gets to here, the second to the last one, this is going to run again. So we will run it the last time. We said it is 8. So we now plus it with 1. Yes, it is now equals to 9. So when we run this and it print Idris, it is 9 already. We now plus it with 1. It will now be equals to 10. Now the program is coming back here. Now see, we said I is less than 10. The moment you see I is equals to 10, that is, it is no more less than 10, this is going to stop and it is not going to print. Now let's say we said I is less than or equals to 10, that it is going to include 10 and we run it. It is not going to stop at 9 again. It is going to stop at 10. If we said while I is greater than 10, this is not going to run at all because we start at 0 and 0 is not greater than 10. That's how it works. So what do you understand here? What we understand is that for this thing to run, this condition will be checked. For this to run, your program or your computer is going to check this condition. Now, do while is just the same as as while, but there is one different thing about it. So let's say do. We said do while. What's going on? Wait, maybe we should rewrite it. Wait, is it? Oh shit! So just finding out, there's nothing like do while in Python. We only have while and for. I'm sorry. So that's the problem of knowing other programming language outside the one that you know. Although there is no while in Golang, there's just for. So but in .NET there's do while. I'm sorry. But so you don't need a do while. Absolutely, you don't even need a while. But you know that's how it is done. So I don't disturb your head or why do you say we don't need something and you are teaching us, just talking about other programming language outside of this one that we are learning. But for now, you need to know all these things. So you can achieve the same thing using different, we use it with print, we use for, we use while, we use two different type of loops. But at the end of the day, they're achieving the same thing. The same thing. What? We are doing one thing more times without having to repeat ourselves. Like we did the first time, we just use print like 10 times. Now all we have to do is declare print just once, and our program is going to monitor it by writing another additional line. Just very simple line, and it's going to achieve the same thing instead of running print 10 fucking times. So yeah, that's the point. So, we already know the two type of loop that we have right now, but we need to explain some other things. Now, what can we do with loops? We can do more things. Now, let's say you want to loop for life. You want to build a program that keeps running for life. There are instances that you want to do this. Absolutely. More like there's the servers, applications like servers, apps, and all. They are running in your background for life. So at the end of the day, how can we run something for life? So in your programming language, you want to run something for life. So let's say you want to do something for life. This is what you do. While true. See, with this program that we just write, okay, is it true? Okay, this true. You are going to run this thing for life. Print. We're running. We're running. See, let's run this. It's going to run for life. It is going to be running. You can see we're running, we're running, we're running. If you want to play around and just play like a game, you can do this. We're running. That's it. Maybe I want to develop a game that keeps running. I will just do this. Why true? Then we write other programming languages. Let's do something. We said this is going to run for life. So what if you want to stop? What if you want to stop? There is maybe you are using for like we use here, or you are using while. You can this thing is going to work in the true. Now let's go back to for. So let's go back to for loop. Yeah. Now we said for if we run this thing, okay, this is going to run for 10 times. Run it again. Let's run it. It's going to run 0, 1, 2, 3 to 10 to 9. Sorry. Now we want to skip 5. We don't want this thing to print if there is 5 here. How do we do it? We don't want it to print this. So we do this. We said if. You can use your if. It is called the if condition. It is a condition. So your for loop is running and you want to find a condition there that you should not run at that time. Now let's say if I equals to 5. That is at the sixth iteration, we don't want to print this thing. What do? Just continue. What does continue does in loop? So what does continue does in loop? The thing it is going to skip. It is going to skip the current loop. Wait, let me write skip the current loop to the next. This is going to skip the current loop to the next. Now let's run this. You will not see that it again. As you can see, 0, 1, 2, 3, 4, 6. Skip the number 5 on to the number 6. Now we don't want this to finish. When it is 7, we just want it to stop. Now let's come back here. It's going to skip at number 5, and we said if I equals to this place 7, we want it to stop. Just use break. This is going to stop. It is not going to print it completely. As you can see, 0, 1, 2, 3, 4, 6. Skip the number 5 and stop before number 7. If you want it to print that one first before breaking, you can do this and it is going to work to print the 7 before breaking. But if you want it to break before 7, you put it here. That's how it works. And just play with this. So we have break and we have continue. Continue to skip to the next one, break to stop it altogether. Now let's go back to our game. We said while true print running, we running. We first print we running. Now we now said I'm coming. Okay, we are developing game, right? You don't just want this to be running for life. You see, when you run this, your game is going to run. Okay, I've not saved this. When you run this, it is going to run for life. But we don't want that. We want our game to be interactive with the user. We want the user to do something, and based on what the user does, we can also have an output. So there's a function called input in Python. We call it input. Now let's write this input. Input. What does input does? It accept it listing. You can see here, read a string from the standard input. What we call the standard input is your terminal here. So if you want to know what a function does, you can just put your cursor on it like this. You can see the prompt string, if given, is printed to the standard output without a trailing new line before ending input. If the user hits EOF, it raises an EOF error. So to get an input from the user, there's a function called input. So when you run this, let's see what happens. You see, instead of running we running for life, it stopped here, expecting an input from the standard studio. You see, if you do this, continue running, then expect an input again, as you understand. Let's close this. We don't just want an input, we want to save it somewhere. Let's do this. We said user input equals to input. You can also tell the user what to input. Enter a number. You want them to enter a number. See, the normal day this input is going to return a string, but we want to save it as an integer. So we use this typecasting that we talked about before. So we turn this to an int by just putting it at the end. So now let's run it. Let's run it again. Okay, we collect the number from the user. We expect them to put a number. So when they use the number, now we can now give an output based on that number. Now let's do this. We said winning norms. Winning norms equals to, you see, we said these are our winning numbers. The idea is that If the user input any number in this list, they won. If not, they lost. So now you understand. You can do this. Yeah. You see, indent must be correct. Now we now said if this user input in winning numbers. That's simple. If the input that the user input is in this winning number, what should we do? We said now print a user you won. Now break. We can just stop it. We don't need it to run again. They already win. If they want to keep running the game, they can run again. But you using break means the program is going to stop and not run again. Now, let's say this they did not win. We now said else. If they did not win, what should we do? Now said we should now say, hey user, you lost. Try again, then break. Now let's run our little game. See, we already developed a game by just teaching ourselves. Now let's run our game. We're running. Enter a number. I will now enter a number that is inside. Enter 5. Enter. Hey user, you won. And the game stopped. Let's run it again. Enter 555. It is not inside the number. Hey user, you lost. Try again. So that's a very sweet game that you can play. In the assignment, you are going to extend this game by collecting the username, and then instead of saying a user, you said a and use their name and tell them they won. You can do this. You understand everything you have been teaching. Thank you so much and see you another time.